It is fading into the constellation of Pegasus, disappearing into the eternal dark. Oumuamua is gone, but it changed us forever. We are no longer just observers, we are hunters. Scientists are building engines to chase a ghost that is already light years away. This is the final chapter. Oumuamua is leaving. It glides through the cold vacuum at a speed of approximately 26,300 meters per second, heading toward the constellation of Pegasus. It leaves our sun behind, which now appears as just one of billions of dim dots in its rearview mirror. We follow it with the gaze of our most powerful telescopes, but even they are beginning to go blind. The interstellar wanderer dissolves into the eternal night, leaving us in a silence that feels louder than its very presence. In this final act of our story, we are not facing the object itself, but rather what it has changed within us. Oumuamua became a cosmic Rorschach test, a mirror in which humanity saw its deepest fears and its boldest hopes. If it was merely a chunk of nitrogen ice or a hydrogen iceberg, then why did it force the world's leading scientists to argue until they were hoarse in the halls of Harvard and Massachusetts? Why did it make us redefine the very meaning of what we call natural? The silence that followed its departure became a fertile ground for obsession. Professor A.V.A. Lubb, a man who put his reputation on the line for the idea of a light sail, was not just defending a hypothesis, he was challenging academic conservatism. He argued that searching for evidence of extraterrestrial life should not only be done through radio signals, but also through cosmic debris in artifacts that could drift for millions of years before accidentally crossing the orbit of a small blue planet. But while scientists argued, engineers began to calculate. The distances in space are unimaginable, but human curiosity is even more boundless. Thus was born Project Lyra, a daring, almost insane attempt to catch the retreating ghost. We understand that we have only a tiny window of opportunity before Oumuamua leaves our reach forever. To overtake it, we will need technologies that today seem like science fiction. We will need to use the gravity of the sun itself to perform a dangerous Oberth maneuver, passing in close proximity to the blazing corona, accelerating our craft to speeds that humanity has never before developed for small probes. 70 kilometers per second, 100 kilometers per second. Every second of delay here on Earth turns into thousands of kilometers, by which Oumuamua distances itself from us into deep space. It is not just a chase after an object, it is a chase after an answer. We cannot allow this mystery to go unsolved, because the price of this ignorance is too high. If it was a probe launched by a civilization that no longer exists, then Oumuamua is a message in a bottle thrown into the ocean of eternity. And we, who accidentally found it on our shore, face a choice: to try and read it, or to let the waves of time carry it back into the abyss. The world has changed. Dozens of new telescopes, such as the Vera Rubin Observatory, are now being tuned to search for new interstellar guests. We realized that our space is not a closed room. It is a thoroughfare through which wanderers from other solar systems occasionally rush. Borisov, the comet that came after Oumuamua, confirmed that interstellar transit is a reality. But Borisov was understandable. It was a comet. Oumuamua, however, remained unique, impossible, one of a kind. Brief pause. CTA. If you feel the scale of this cosmic mystery, join our exploration of the unknown. Subscribe so you don't miss the finale of this trilogy. We continue to stare into the void. 5 years later, 10 years later, the debates do not subside. Every new anomaly, discovered in the data from Spitzer or Hubble, adds fuel to the fire. We double-check the light curves. We create computer models, trying to understand how an object of such a shape could even form naturally. A ratio of length to width of 10 to 1, or 1 to 10, depending on how you look at it. It is not just an asteroid. It is an anomaly that requires a different approach. The ease with which it made its non-gravitational surge continues to haunt astrophysicists. If it was hydrogen sublimation, then where are the traces? If it was radiation pressure from the sun, then how thin must this object be? The answers we receive give birth to even more complex questions. We stand on the threshold of a new era, the era of interstellar archaeology, where we no longer wait for a signal, we follow the trail. The trail is cold, but the mathematical breadcrumbs left behind by the intruder are burning bright. To catch a ghost, we must become ghosts of the machine, projecting our consciousness and our senses across the interstellar threshold. Project Lyra is not just a mission, it is a declaration that humanity refuses to be a passive bystander in its own cosmic neighborhood. The orbital mechanics are unforgiving. Oumuamua is already beyond the orbit of Neptune, heading into the deep, freezing territories where the sun is nothing more than a very bright star. To bridge the gap, we contemplate a journey of 20, 25, or even 30 years. A generation-long pursuit, where the scientists who launched the probe might be elders by the time the first close-up images flicker onto our screens. We speak of the solar Oberth maneuver, a terrifying dance with the source of all life. Imagine a spacecraft, protected by massive carbon shielding, diving toward the sun, passing within a few solar radii of the surface. In that moment of maximum gravity, we fire our engines, stealing velocity from the star itself, flung out like a stone from a celestial sling. We must reach speeds of over 40 astronomical units per year, just to have a hope of seeing that jagged, bruised red surface once again. But what will we find? If we reach it in the year 2054 or 2060, what state will the messenger be in? Will we find a tumbling rock, or will we find a dormant engine, waiting for a spark? There is a haunting possibility that Oumuamua was not looking for us. It was simply passing through, a piece of galactic driftwood, a fragment of a planetary crust shattered by a tidal disruption event billions of years ago. Yet, the light sail hypothesis remains the most elegant solution to the most stubborn problem. If Oumuamua was a sail, then it was thin, thinner than a millimeter, a vast golden or silver sheet designed to catch the breath of stars. Even if it was discarded, a derelict from a civilization that has long since turned to dust, its existence changes the probability of life in the universe from a question to a certainty. It means the great silence is not because nobody is there, but because we have not been looking for their remnants. Professor Loeb often speaks of interstellar archaeology, the idea that the universe is a vast graveyard of technological dreams. Most civilizations may not last long enough to meet face to face. The distance between two intelligent species in time might be greater than the distance in space. Oumuamua might be a tombstone, a silent witness to a culture that mastered the stars and then vanished. We are now building the eyes to find the next one. The Vera Rubin Observatory, with its 8.4-meter mirror, will scan the entire southern sky every few nights. It will be a sentinel, a guardian of the gates, ready to catch the next flicker of an interstellar visitor before it reaches our inner sanctum. We expect to find one such object every year, once our technology catches up to the reality of the cosmic transit. Brief pause. CTA. The abyss is no longer empty. If you want to see what we find next, make sure you are subscribed to this channel. The hunt has only just begun. If Oumuamua was the first, then we were like children seeing a ship on the horizon for the first time, unaware that the ocean is full of them. We must prepare our space guard, our interceptors, ready to be launched at a moment's notice. We cannot afford to let the next messenger pass us by, not when the stakes are the very understanding of our origin. As Oumuamua disappears, it leaves a shadow over our pride. It reminds us that we are young, that our telescopes are small, and our reach is short. But it also gave us a gift. It gave us a target, a reason to look beyond our own orbital shell. It forced us to think about sails made of light and ships that do not need fuel. It turned our gaze from the mud of our internal conflicts to the shimmering possibilities of the interstellar sea. The pursuit of Oumuamua is not merely a matter of speed. It is a battle against the fundamental geometry of our star system. To reach an object that refuses to slow down, we must rethink the very essence of propulsion. Project Lyra proposes a symphony of gravity and fire, a trajectory that looks more like a grand celestial clockwork than a simple flight path. We must discuss the sheer scale of the engineering required for the solar Oberth maneuver. Our probe would need to endure temperatures reaching over 2000 degrees Celsius, shielded by advanced carbon-carbon composites that can dissipate the immense thermal energy of the solar corona. This is not just a flyby. It is a plunge into the heart of the furnace. We would drop our perihelion to within a few million miles of the sun's churning surface, where the magnetic field scream and the plasma loops like titan serpents. At the precise moment of closest approach, the solid fuel boosters would ignite, adding their chemical fury to the gravitational kinetic energy we have already stolen. This maneuver would provide a delta V, a change in velocity, so immense that the probe would be flung into the interstellar void like a bullet from a railgun. We are talking about speeds exceeding 150,000 miles per hour. And even then, the journey would be a silent, lonely vigil lasting decades. The spacecraft would have to be autonomous, an artificial intelligence capable of making life or death decisions without the guidance of Earth. Because at those distances, a radio signal would take hours, then days, to return a single yes or no. But why spend billions of dollars and decades of human effort to photograph a receding speck of light? The answer lies in the aesthetics of the unknown. Oumuamua shattered our sense of cosmic normalcy. Before its arrival, we assumed the universe was full of things we already understood: ice, rock, gas. But Oumuamua had no coma, no tale of outgassing water or carbon dioxide. It was dry, yet it accelerated. If we find that its surface is covered in microscopic patterns, or that it possesses a hollow structure, our place in the hierarchy of the universe changes instantly. We must also consider the garbage hypothesis, a sobering thought that Oumuamua might not be a functional probe, but a piece of ancient, discarded technology. Like a plastic bottle floating in the middle of the Pacific Ocean, it tells us someone was there, but it doesn't mean they are watching us now. It could be a fragment of a solar sail that failed 1 million years ago, drifting aimlessly through the light of distant pulsars. Until we reach it, We are like archaeologists looking at a single pottery shard from an empire we never knew existed. And then, there is the silence of the other stars, the great filter. If the galaxy is indeed teeming with life, why was Oumuamua the first visitor we noticed in all the centuries of modern astronomy? Perhaps they are everywhere, and our eyes have only just become sharp enough to see the shadows they cast. The legacy of the silent guest is that it forced us to look at the dark matter of biology, the hidden, quiet presence of others who might be sharing this vast spiral arm with us. We are currently developing the LightSail 3 technology, inspired by the very possibility that Oumuamua itself used the pressure of photons to navigate. Imagine a fleet of thousands of tiny, gram-scale probes, propelled by massive ground-based lasers, flying at 20% of the speed of light. Oumuamua has turned the breakthrough Starshot from a theoretical dream into a survival necessity. If we cannot reach our neighbors, we must at least be able to reach their ruins. Brief pause, CTA. We are digging into the deepest secrets of the void. If you want to witness the moment we finally bridge the gap between stars, ensure your notification bell is active. Stay with us on this journey. As we look at the data from the Spitzer Space Telescope, we realize the limits of our current reach. Spitzer looked for the heat signature of Oumuamua and found nothing. This nothing is perhaps the most significant data point we have. It means the object was smaller than we thought, and much more reflective. High albedo, the shimmering quality of a polished surface, metal, or perhaps something more exotic, like a thin layer of organic polymers designed to survive the harsh radiation of the interstellar medium. Every year, our mathematical models of the object's rotation become more complex. It doesn't just spin, it tumbles, a chaotic movement that suggests an external force once acted upon it. Did it collide with another object in a distant star system? Or was its departure from its home world a violent, cataclysmic event? The bruises on its surface, that dark red hue, tell a story of billions of years of exposure to cosmic rays. It is a seasoned traveler, a veteran of the void, and we are merely a footnote in its multi-million-year diary. The arrival of this wanderer has forced us to confront the most chilling silence in the history of science, the Fermi paradox. If the universe is a sprawling garden of life, why is the air so still? Why have we spent decades listening to the static of empty frequencies, only to be visited by a silent, unanswering monument? Perhaps Oumuamua is the answer itself, a subtle hint that the galaxy does not communicate through screams, but through whispers and shadows. We must explore the concept of techno-signatures in a way we never dared before. Traditionally, we searched for radio waves, for the deliberate hello of a distant civilization. But Oumuamua suggests a different reality, a reality of passive presence. It is the difference between a lighthouse and a shipwreck. Both tell you that someone was there, but only one wants to talk to you. If our corner of the Milky Way is filled with these drifting relics, then we are living in a cosmic museum, surrounded by the artifacts of civilizations that may have peaked when Earth was still dominated by single-celled organisms. Consider the stochastic visit theory, the idea that interstellar objects like Oumuamua pass through our system at a rate of several thousand per year, but they are simply too small, too dark, or too fast for our current instruments to catch. This means that at any given moment, there could be a dozen interstellar messengers within the orbit of Mars, and we are effectively blind to them. We are like people standing in a dark forest, unaware of the hundreds of animals watching us from the shadows, simply because we lack a flashlight. This realization has led to the birth of the Galileo Project, a dedicated systematic search for extraterrestrial technological objects near Earth. We are no longer content with accidental discoveries. We are deploying artificial intelligence to scan the skies for non-ballistic trajectories, for movements that do not fit the elegant, predictable curves of Keplerian motion. If another Oumuamua enters our domain, we will not be caught off guard. We will have our high-resolution sensors ready to capture the microtextures of its skin, to analyze the chemical composition of its wake, to finally see the face of the unknown. And what if the object was not a drone, but a scout? Some theorists suggest the Banal sphere or anneal cylinder fragments, remnants of habitats that once housed millions of souls. Could Oumuamua be a piece of a shattered world? When we look at the bruised red color of the object, we are looking at tholins, complex organic molecules that have been baked by starlight for eons. These are the same chemicals that cover the surface of Pluto and Titan, the building blocks of life, hardened into a protective crust by the relentless fire of the galaxy. If we catch it, if Project Lyra manages to draw alongside this Titan, what is our protocol for interstellar diplomacy? How do you greet a guest that may have been dead for 10 million years? We are drafting the first chapters of a new law, exojurisprudence, deciding who speaks for Earth when we finally touch the cold, metallic or organic surface of a visitor from another star. Is it a scientific specimen, a sovereign entity, or a holy relic? Brief pause, CTA. The boundaries of our world are expanding faster than we ever imagined. Join the conversation in the comments below. If you were the one to first touch Oumuamua, what would you say to the void? Subscribe and stay tuned for the final revelation. The psychological impact on our species cannot be understated. For the first time, the aesthetics of the unknown has moved from the pages of science fiction into the peer-reviewed journals of astrophysics. We are growing up. We are shedding the skin of our planetary childhood. Oumuamua was the first knock at the door, and even though the knocker has already walked away, the sound continues to echo in our minds. It has unified scientists across borders, because the challenge of chasing Oumuamua is too great for any one nation. It requires the combined genius of the entire human race. We are looking at the Solar Gravitational Lens mission, a plan to send telescopes so far out, 550 astronomical units away, that they can use the Sun's own gravity to zoom in on distant exoplanets and on objects like Oumuamua. From that vantage point, we could see the cities of other worlds, or the thrusters of other ships. Oumuamua has accelerated our timeline. It has given us a sense of urgency, a cosmic deadline. We are no longer just dreaming of the stars. We are preparing for the inevitable moment when the next shadow falls across our path. The shadow of Oumuamua is longer than the object itself. It stretches across our future, pointing toward a destiny we are only beginning to comprehend. As the silent guest fades into the velvet dark, we are left with the most profound realization of the 21st century, that we are ready to listen, but more importantly, we are finally ready to sail. We must envision the final moments of Project Lyra, years from now, when a small, human-made craft, powered by the ghost of a nuclear engine or a shimmering sail of its own, finally draws close to the Titan. The cameras, cooled to near absolute zero, will begin to capture the impossible. We will see the textures we have only dreamed of, the jagged edges of a world that has crossed the interstellar desert. We will look for the signature of an architect, a weld, a seam, a sensor array, or perhaps just the ancient, weathered scars of natural cosmic violence. Whatever the image reveals, it will be the end of our innocence. If we find a machine, we are no longer the kings of the garden, but students in a vast, ancient library. If we find a rock, we learn that nature is far more creative and far more mysterious than our physics once allowed. Oumuamua has taught us the humility of the unknown, a reminder that the universe is under no obligation to be understandable to us, and yet it has invited us to try. The legacy of this visit is a new unity for our species. We are no longer just citizens of nations, but representatives of a planetary intelligence that has finally noticed its neighbors. We are building the light sail armadas. We are tuning the ears of our radio telescopes to the frequencies of the impossible, and we are waiting. We know now that the door is open, and that at any moment, another flicker on a screen in Hawaii or Chile could signal the arrival of the next messenger. As we close the chronicles of the first interstellar visitor, we look up at the constellation of Pegasus, where Oumuamua now wanders. It is a tiny, invisible speck, carrying its secrets into the void. Perhaps, in 1,000,000 years, it will pass through another system, and another civilization will look up in wonder, asking the same questions we asked. This is the eternal cycle of the cosmos, a relay race of curiosity across the light years. We are the event weaver, and we have followed the thread of this mystery from its first appearance to its final departure. But the story of humanity and the stars is only in its opening chapter. The silent guest is gone, but the echoes of its footsteps will lead us to the edges of the galaxy and beyond. Farewell, traveler. Thank you for waking us up.